Now, just like your Z transform, just like your Laplace transform also, this x of Z also has two types, right? Two types. That is we have is the bilateral Z transform and the unilateral Z transform, right? Bilateral Z transform is this is the equation. This is the equation for bilateral uniform. That means two side, both on the negative side as well as the positive side, right? So that will be sigma n is equal to minus infinity plus infinity x of n z raised to minus n. For unilateral Laplace transform, the equation will become x of z is equal to sigma n is equal to 0 to infinity x of n into z raised to minus n. Okay, this is how we define it. Okay, now one more thing I need to tell you is the most of the equations that we are using over here would be the geometric progression equation. We know that geometric progression equation, there is an equation that we have learned in school, that is if we start with a plus ar plus ar square plus ar cube up to infinity, yes, up to infinity, this can be written as a by 1 minus r. This is how we define the equation. This is called as the geometric progression equation. Here a is the nothing but the first value of your progression, the very first value of your progression, and r is called as the common factor. Okay, and you can apply this equation only if r is less than 1. You can only apply this condition only when r is less than 1, and we apply this equation in all this case. So always we consider that r is less than 1. Okay, this is how we apply this equation. This equation you need to study when we are applying all the problems related to Z transform. Okay, simply remember this equation, a by 1 minus r, where a is the starting value and r is the common factor. Okay.